It's recorded.
Thank you. Hi, people watching the recording. We just had a nice time with to-doodle number 101. I'm sorry I forgot to record. Oh, well, Peter Rabbit misses you. Now we're talking about what we've done after doing that to-doodle. Tuesday, we did applying order of operations. We talked about PEMDAS and terms and things like that. That was all great. Evaluate a variable for a given value. We just did that. We were plugging things in, and we noticed that we could do with that with formulas and expressions. Remember, they're an expression because there's no equal sign in these things. Expressions with letters are weird. Is this thing positive or negative? It could be positive, it could be negative. We are not sure. So we've plugged things in. We've done that. Okay, back over here. Simplifying by combining like terms. We haven't done that one yet. So that one we still have to do. Translate a word problem into an algebraic expression. We did that a little bit last time. I'm going to bring everyone to me because I see people wandering around. Using rules for integer operations to simplify things with positive and negatives. We just did that. This page here. Make equations with fractional and decimal coefficients nicer. We haven't done that one yet, nor have we done any of the others. So this is where we are at 6:30 on our second day together. Everyone okay? Okay, I'm going to scroll down a little bit and right in that place that says note here, I'm going to get rid of my note here because I really don't want that. Just stick it over there. I'm going to go on to another page I have open and grab a title. Whoops, nope, not that title. I want this title. Okay. Okay, so if I exercise, I burn energy. And the table I'm about to make is not going to be accurate. If I say, how many calories do I burn when walking? I'm just estimating. How fast am I walking? Am I walking up a big hill? Am I walking slowly and chatting to people and things like that? But for now, I'm just going to say that walking burns about 0.04 calories per pound per minute. I'm going to make a quick comment. I just said 0.04 or 0.04. Do I need the 0 right here?
Technically, no.
No, I could just write 0.04 and it's the same. If you were sitting next to me in office hours and we're talking about this together, I would just say 0.04. But if I am lecturing, then to help your ear get kind of a heads up, decimal is coming, then I'm going to pronounce that 0.04 and write it. But that doesn't mean it's better. That's just because I'm lecturing. As a tangent, if I was a stenographer in a court of law, I would write kind of the formal name, right, in the tuxedo or nice dress for this number. What's the kind of the formal name for 0.04? If it was 0.4, that would be 4 tenths because the first place value is named tenths. If it was 0.04, that's tenths. And then the next place value is hundredths, so 4 hundredths. Everyone remember that? And that's way too big a font. I don't want such puffy 4s. Why did it do that? Okay, so 0.4 would be 4/10. And 0.04 would be 4/100. But that's not really what we're talking about. Okay, let's do some math. So if I'm walking, or maybe one of you are walking, who's going to be brave and either tell us or lie about your weight? Go ahead, no one will know.
I'll share it. This is easier. My email, it's sent to, like the invite itself is sent by personal, because when we do the phone call, it's.
Okay, I'm gonna edit my note here. Okay, who is walking? Who's gonna tell me their weight? I saw the 250 first. Who was the 250? Thomas? Okay, Thomas is walking. For how many minutes are you walking, Thomas? Just call it out or type it out or put it in chat or something. Or we could make it up. How long do we want Thomas to walk?
One hour.
1 hour, yeah.
Okay, 1 hour. He weighs 250 pounds. How many calories does he burn? So calories per pound per minute. So we take that 0.04 and we're going to multiply it by his pounds. And we're going to multiply it by the minutes. Uh-oh, we don't have minutes. What do I have to do?
60 minutes.
60 minutes. I can't just put in a 1 there. What do I get? 0.04 times 250 times 60. So he's burnt 600 calories. Everyone okay with that?
Damn, is that actually how many calories you burn walking?
Yeah, that's how many calories you burn walking. Again, it's an estimate because maybe you walk up Donald Street and someone else is walking very slowly while talking on their phone someplace flat, but it's a good estimate. Let's do another one. Basketball is about 0.06. So I'll write that down. And again, this is an estimate. If you're just kind of sitting around and letting other people do all the work, then that's not going to help you. But basketball is about 0.06. Let's pick on someone else. Thomas did a great job being our first brave volunteer. Who's going to play basketball for an hour or for some time?
I will. We'll do 215 for 45 minutes.
So Anthony,
How much
plays basketball for 45 minutes. He weighs 215 pounds. So we're starting at 0.06 because basketball is more intense than walking. 15, 45 minutes. And what do we get? 0.06. about 581. I'm gonna round up. There's no way I know this to the nearest half a calorie, right? Our metabolisms aren't that routine, even if the math was that correct, but we're just estimating. So about 581. Everyone okay so far? Now I'm going to get more tricky. So it's also true that dancing is about 0.06. Again, this isn't quite precise because there's lots of things that we call dancing. Maybe you're very intense, maybe you're barely moving. And I'm going to make a new story. So I'll use one of my kids. Simon dances for 15 minutes and then plays basketball for 25 minutes. He's only 15, so he weighs 110 pounds. He probably weighs less than that. How many calories does he burn? So, oops. Yeah. So basketball and dancing are both 0.06. How many calories does Simon burn? What should we do?
For 25 minutes.
If it helps you, I think I'm allowed to take these parts and change their color. That's kind of hard to see. Let's put the answers in blue. So what do we do for Simon?
So since both activities are 0.06, could you just combine the amount of time for both activities?
Sure.
Like combine the 25 and the 15 and write the equation that way, which comes out to 264.
Yeah, one moment. I'm going to move this form 4950, which seems like an awful lot. That's like a huge amount of calories. Well, and I'm not getting my mouse cursor. Stop scrolling thing. Okay. There we go. Okay. So I'm going to actually do that second because you're completely correct, but I want to do it the old way first. So I could do 0.06 or for dancing, 0.06 times 110 pounds times 15 minutes, and whatever that is. $99. And then for basketball, 0.06 times 110 times 25.
165.
65. And then add those together for a total of 264 calories. Or together 0.06 times 110 pounds times 15 plus 25 minutes. Just do it all in one step. Everyone okay with that?
Yeah.
One of the things we're supposed to be talking about is up here, combining like terms. And what that means is just what we did. It's nothing more special than that. If I have 1x and then I get rid of 5x's, I'm down to negative 4x's. If I have so many minutes of exercise and so many more minutes of the exact equivalent exercise, I can just add them together. No problem. So that's all that combining like terms is. Okay. I want to look at one of our textbooks a little before we get into making equations nicer and things like that. I'm going to check in with Kayla, who has to put a toddler to bed. Do you want me to go on until 7 for 14 more minutes, or is this a better time for us to take a little break? Is that a yes, keep going, or a yes, take a break? I am still not getting a clear answer from her. Okay, well, I'm going to keep going because she seems okay. Holler if I'm guessing wrong. Okay, back over here. Let's look at our textbooks. Which textbook do you want me to show off first? The free one or the fancy one?
Might as well start with the free one first, I guess.
Free one first. Okay. I'm wanting to talk about making equations nicer. So let's look for that. Fractions, no.
Which one's the free one?
0.4 to 2.7. Constants on both sides. Let's do that one. So I have some equations. They're doing some review. They have some nice pictures, and they've talked about solving some equations. I'm not sure we're good at this yet, actually. Maybe I'm jumping ahead. Let's try. They're not
What
even,
chapter are you on?
they're not even giving you easy ones to start without decimals, but let's try this. Okay.
I just went back for no.
Come back. 5x equals negative 27. Is this too much to start with? Should we do one without a negative as our first one?
Let's go for it.
Let's go for it. Okay, we'll be brave. We'll go for it. So I have 5 somethings, and together they're negative 27. How would I find out what each of those somethings is?
We can move 5 and divide 27 divided by 5.
Yeah, if I do something to both sides, that works out okay. So I can divide both sides by 5. 5 divided by 5 is 1. I have just one of these x's left. And what's a negative 27 divided by 5? Yuck, negative 27
Negative
divided by 5
5.4.
minus 5.4. Okay. Now, I'm going to talk about this a whole lot. First, are we surprised that our answer is negative?
No,
No, if I have 5 things and together they're a debt, then each of them must be debts because they're all the same. It's not like I can have, have some positive money and some negative, but overall it's negative. No, these are all the same thing. So they all have to be debts. Second, some of you would rather write this, and it's perfectly fine, where instead of a division symbol, you make a fraction bar. That's how you've been taught.
Yeah, that's what I did.
that's
Yeah, it's the,
There's nothing wrong with that. It's exactly the same thing. It's just showing divided by 5 on both sides. The reason I don't do that is what if I had a different problem that was 2/3 x equals 6. Then if I do what you're just used to doing and say divided by 2/3 on both sides, then I get x by itself. And what's 6 divided by 2/3? 6 divided by fraction 2/3, 9.
Yeah.
The problem is this looks a little bit like some weird
Yeah,
kind
it's
of
fractions,
totem
but I really
pole,
like this. So
especially without colors. It's really hard to see what's happening here. So that's why I don't like using this fraction bar to mean division. It's not wrong, it's just visually challenging. That makes sense? So that's aside, that's not really what we're doing. Okay. Another comment. My answer here was a decimal. Is that okay? Sure.
Okay.
If you are going into physics or computer programming, you like decimals. If you're going into carpentry or baking, you like fractions. Could I change this into a fraction? Certainly. I could say that it's minus 5 and 4/10. Remember those formal names for fractions we did a moment ago? And then somebody made the annoying rule that fractions don't count as done until they're completely reduced. So I can say it's negative 5 2/5 instead of negative 5.4. But I don't know which one your future career plans are in. Are you in carpentry and baking and you want fractions? Are you in physics and computer programming and you want decimals? I don't care. Calculators, including the one you're allowed to do on the GED, have a button that say, let's switch back and forth between fractions and decimals. So it's not even a big deal if the calculator spits out the decimal to go to the fractions. And once I'm physically there next week, I can take out the GED department upstairs on the 4th floor has loaner calculators of the exact brand you're allowed to use on the GED, and we'll show you how to use all the special buttons. So that's not something we're picky about in Math E. Okay, everyone okay with this? You think you are. Okay, we'll see if you really are with our last Jamboard. I'm going to put this up in the chat, but then we're going to take our break. So get more tea, put kids to bed, have a snack, use the bathroom. If you want a head start to look smart, you can look at the Jamboard, but go stretch your legs, get your blood moving, help your blood sugar. See you in 10 minutes. And I will remember to pause recording, but somebody help me remember to restart it when we get back. Oh, recording. Okay, so we did some solving of a one-step equation. we called it one step because all we had to do was one thing. The divided by 5 on both sides. We're going to see more about how this works. Again, the theme for this week is to help you think carefully about things so that even if you've seen them before, they make a lot of sense, and the things that we build on in the future will go more smoothly. So we're going to look at the equation 4 times b equals 20. I've put it on our whiteboard also so that we can write things there. How have you been taught how to solve it? As a side note, guess and check does work because b is not only a small number, but what we call a counting number, not a decimal, a whole number. And there's also the do the same thing to both sides of the equation. Not a surprise, because again, we just did that. So the question I have for you is, assuming that pictures help, and I'm acknowledging pictures don't help everyone, here's a balance scale. It says that 4 b's equals the 20. They're balanced. But where does the solving happen on the picture? So I'm going to go here, make it a little bigger. Okay, tell me how to solve 4 times b equals 20. I'll be your secretary.
I think what you're
Five.
doing is showing on the,
Someone be loudest so I can hear you clearly.
You're not
B-
sharing your screen.
B equal 5.
b will be 5.
Yeah.
You could just check 5, 5, 5, 5 makes 20. Or if you didn't guess and check, how would you solve it? What process would you do?
To actually solve, you would
So-
divide by
20 divided by 4.
Divide by 4. There's a times 4 stuck onto b. So the opposite of that is a divide by 4. The b gets by itself.
no,
David?
It's fine.
it's not.
Hey,
sharing.
David,
Yeah.
the students in the classroom can't see whatever it is
Oh,
you're.
you're not sharing my screen. Okay, thank you. Sorry. Let me go back a bit then, because so here was the to-doodle page where I was reading out loud, but then I put it here. Thank you for hollering. Something else that will be easier once I'm actually there. Okay. So my question is, this divided by 4, where does that happen in the picture? If pictures help you, where's the dividing by 4 hiding?
That's kind of just the 4 b's, I guess. I would think.
It could be that I just care about one of the b's. That's the only one of the 4. That's on one side. That's this part over here. Where's the other divided by 4?
On the other side, at the 20.
So I can take my 20 and chop it into 4 things. Whoops, that's kind of big. If I did that, how big would each piece be?
5.
5.
Everyone happy that the 4 different 5s makes
Hey.
20?
I think he can.
And again, one of them is ours, and the rest we get rid of them. And that's why B is 5. If you're not a picture person, that might have just made it worse, and that's okay, ignore the picture. But if you are a picture person, maybe now you're understanding more about where that came from. The next one is P divided by 6 equals 8. So I have a pizza. I'm calling it P for pizza. And I have only 1/6 of the pizza. That's my piece. And that's equal 8. I'm not sure what 8 is. Maybe 8 pieces of pepperoni or 8 bites or something like that. So 1/6 of the P is 8. How would I solve this one? It's probably helpful to first ignore the picture and just do it the way you've been taught.
multiply multiple 8 and 6 together.
Yes, but I want to do the same thing to both sides because I can't just multiply two numbers because I feel like it. So I don't have very many options in algebra. One of the options we've seen before was I can do the same thing. Where was it? Same thing to top and bottom. Right. This is one of my things in my toolbox. I can multiply or divide a fraction top and bottom by the same thing, and that doesn't change the fraction. By the way, why is that true? Why can I take 4/10 and divide by 2 top and bottom just because I want to?
It's the same overall whole, it's just smaller numbers.
Yeah, what I could write that, pardon my tangent, as 4/10 and then divide it by 2/2. And 2/2 is just another way of saying 1. So I'm just doing a times 1 or divided by 1, and that doesn't change anything. So ignore that tangent for now. So that's one of my toolbox items. And the other thing I can do is take an equation and multiply or divide or add or subtract the same to both sides. And later you'll see we can do like square roots or other things too. But that's because if these two things are equal, then if I do the same thing to both, they stay equal. So those are my two toolbox items. I have kind of like a wrench and a hammer, or however you want to think of it. So I like what Pasomsuk said. We are going to end up multiplying the 6 and the 8 and getting 48, yes. But what's my excuse for doing that? What can I actually write here that I'm allowed to write?
You can cut the piece of P until eight
And-
times.
Times, and the opposite of divided by 6 is going to be times 6. And I'll do that to, if I do that to one side, I do that to the other. I get my P by itself. Divided by 6 times 6 cancels out. And then 6 times 8 is 48. Everyone okay with me? Sorry to be all pedantic about that. I could have just said, yes, Pasumsuk was right, it's 48. But I want to be clear, especially while I'm lecturing in the first week, that we're only allowed to do certain things. We have to like justify what we do. Okay, where's the times 6 hiding in the picture? Again, completely ignore this if you're not a picture person. But if you're a picture person, where's my times 6? Someone is drawing. Victoria says, fill in the rest of the pie. So there's my other 6 piece, my times 6, right? The other pieces are there. And then where's the times 6 on the other side? Just explain it out loud if you don't want to have to try and draw funny, because it's hard to draw funny.
What? Wouldn't you just do the same thing on the other side?
Yeah, I'm going to make 6 more copies of that 8. Or 5 more, so that there's 6 total. And if each of them is 8, and I have the 6 8s, 1, 2, 3, 4, right? Then all of that together is 48. So my whole pie, my whole P is 48. Everyone okay with that one?
Yeah.
Okay, what if it gets ugly and worse? What if make this smaller? What if we had a very similar thing, but instead, okay. Actually, I don't want to do that. I just want the frame. And it's not letting me. Okay, new frame. Yeah. what if instead of 4 times b is 20, I had something annoying like 4/10 times b is 2/100. I could just do the same thing and it works. I could say the opposite of times 4/10 is divided by 4/10. So I'll do that to both sides. Then I get b by itself. And what is 2/100 divided by 4/10? Remember, dividing by fractions, you flip and multiply. So I'm going to make it times 10/4. And oh, look, I can do some canceling. Maybe we need to review that. And
Oh,
there's
yeah.
more canceling. And I wind up with 1/20. Everyone okay with my work on that page so far? That was kind of ugly though. I don't like doing fraction math if I don't have to. So I could do exactly the same thing a different way. I could take the same problem. 4/10 times b is 2/100. And I'm going to clean it up before I get started. What happens if I just do a times 10 on both sides? That would mean that this 10 and this 10 cancel out. Everyone okay with that part? We haven't talked about canceling. I'm a little afraid I'm going too fast.
Oh,
But
right.
this 10 and this 100, I need this to be bigger. So what I really want to do is multiply both sides by 100, the number with the most zeros. Then not only will that cancel out nicely, but here, the times 100, 10 of it will cancel out with this 10, and the other 10 will do the 4 into a 40. Because a times 100 is just a times 10 and a times 10. So that one cancels out, and the 10 and the 40, the 10 and the 4 will come together. So then I can get, whoops, right color. 40 times b equals 2. Now when I get b by itself, I of course get the same answer, but to me this side was a lot cleaner than that side. So up to you. We'll talk about this more and do more of it in different situations. But in our to-do items back up at the top, when it says make equations nicer by multiplying by the lowest common denominator or powers of 10, that's the kind of thing we're talking about. I wanted to take a quick break before talking about inequalities, because now we have done both of these. and talk about using a textbook. The free textbook we have has these show and hide solutions, which is very nice. Because you can try it yourself and then see if you got it right or not. The fancy textbook doesn't do that. There's no show and hide. Instead, it has, let's try a similar one with that orange button. But you could do the same thing. If I had this book physically in front of me, then I could take a piece of paper and put it in front. Since I can't show you that right now, I'm actually going to just take a random rectangle I made and say, oh, I'm going to go line by line. How would I do this? Well, first I'm changing things this way, then I'm doing that. Okay, for this one, I'm doing that. So see how I'm moving a rectangle down the page? So that's a good way to use example problems when you're playing with a textbook. Okay, back to just this one. Okay, I did want to look at this textbook a little just to see how thorough we are. Holler if you want me to do any of these on the whiteboard. I've been jumping around a bit topic to topic because I'm not sure what's review for you and what's not. But we have half an hour left, maybe 25 minutes left, and whatever is useful to you. If you don't ask me enough questions, then I will get to the inequalities things. But if we would just wait and do that on Tuesday, that's fine also. Also, help me remember before we say goodbye to talk about homework very briefly and ask about office hours. Normally, I've set up my office hours Monday, but Monday is a holiday with MLK Day. And so if you want me to be either in Zoom or in person before Tuesday night's class of next week, I can arrange to make that happen. Okay, so we talked about combining terms, that if I have 3x and 4x, can I highlight this thing a little bit? That's the same as just 7 of those x's. Or if I had 7 somethings, whatever a is, but I owed somebody 10 somethings, then I'm in debt 3 of those somethings, and so on. Anyone want me to do things like this example 1? I'm going to make it bigger too, so you can see. No one? Okay, I'll keep going. Now they're making them longer. They have 4 pieces instead of 2 or 3. Anyone need more of that? Now they're saying to distribute, to take this 5 and multiply it by both the 2x and the -8. Has anyone ever shown you drawing this like rectangles?
Oh,
No, let's do that. One moment. Shrink things down. Make another frame. Okay. Zoom, oops, zoom in some. Okay, let's talk about rectangles. No, come on, paste. You can paste. There we go. Good whiteboard. Okay, everyone knows how to multiply 31 and 25 by hand. I hope you never need to do that, but you've been taught this before. What I do want to show is that the process that I learned back in the days of the dinosaurs isn't what my 12-year-old learned when he went through elementary school recently. Now they do this weird rectangle method. So if you either have or about to have kids going through school in Eugene, then here's the rectangle method. So when your kid brings home math homework, you're not confused saying, this isn't how I did it. So, I am going to make a rectangle.
I don't know, I have a 13-year-old son, so it's probably useful.
See. I don't know, I'm just curious, I've never heard of that.
Okay, so how the rectangle method works, is this big enough, by the way? I can certainly make it bigger.
It's
Be this right now.
Big enough, okay. I'm going to say that 31 is 30 plus 1. Put each place value along the top of the rectangle. And similarly, 25 is 20 plus 5 going down the rectangle. Then I'm going to take those pluses and make, that's a terrible straight line. Okay. Remember how terms, we made separations where pluses and minuses were outside of parentheses? We're kind of like that. Now I'm going to multiply in each box, going across and down and seeing where they meet, like we're playing Battleship. Hopefully people still play Battleship or you don't know what I'm talking about. So 20 meets 30. What is 20 times 30? That's going to be 600. Oh, can't see light yellow. Never mind. Orange? Okay. Now we're having 20 and 1 meet together. What's 20 times 1? That's just 20. Now we're having 5 and 30 meet. What's 5 times 30? That's 150. And lastly, we have 5 and 1 meet. What's 5 times 1? Oh, that's just 5. I can do these easily because 2 times 3 is 6 with 2 zeros stuck at the end. Or 3 times 5 is 15 with 1 0 stuck at the end. You've seen this kind of thing before.
Well,
When
Okay.
you're done, how do I get an answer from this?
add it together.
Just
Add it together, add them all up. Whoops. Everyone okay with that?
Yeah.
Yeah.
And hopefully my careful color coding has shown you why these are equivalent things. There's the 150. There's the 5. There's the 600. And then here's the 20. Now we can do the same thing with these problems. What's 5 times 2x minus 8? Well, it works exactly the same way. So 5 times 2x minus 8. By the way, these both look like x's, so I'm going to start being picky and saying, I want to make this not an x in the kind of multiply way, but use dots for multiply. So we never have to worry now if my x's are letters or times symbols. You are welcome to use x's as time symbols as long as it's not too confusing. Okay, rectangle. Ta-da! We have 2x minus 8, and we have 5. So 5 times 2x, well, 2x and 2x and 2x and 2x and 2x. That's 10 of those x's. And then 8 and times 5 is 40, but this 8 is a minus 8, so I need it to be a negative 40. And then when I put it all together, I get 10x minus 40. So if you have seen before something about multiply the 5 in both places, but no one's ever explained why it worked, then stare at this. Say, okay, I see why it works for the multiplication I know. And now I'll kind of meditate on it until it makes sense with the algebra also. Does anyone have good words to help me explain this?
Nope.
No. This is, by the way, why I have avoided teaching algebra for 20 years. Everything else in math before algebra, I learned the way everyone else did, right? First, you learn to do multiplication in this long process. And then you kind of figure out why it works, breaking things up into pieces and adding it together, right? Why does long division work? When I do long division, first I multiply and then I subtract, and then I multiply and then I subtract. Why does repeated multiply subtract patterns make equal size piles? Because division is about equal size piles, right? First, I just learned to do it. And then later on, I figured out, oh, that's what's happening, really. I can show you that, by the way, if you want to know. So everything else before algebra, I had to learn to do the process because I memorized it. And then, oh, that's actually what's happening. But for algebra, the first time I saw this, it just made sense. So I'm kind of nervous that, well, if it doesn't make sense to you, I don't have the right words to tell you because I never had to go through both steps of just memorize it and then, oh, that's why. So help each other with words if I don't have them. Maybe I'll be creative and get the words as I need them.
So are kids in school doing like a division version of the box as opposed to long division now?
Yes,
What?
yeah, it's wacky. I
Huh.
agree. I don't get it.
I mean, it's simpler, but God, it's with my brain to process.
It's
Oh,
easy for the kids, my kids like
Yeah.
learn.
I mean,
things,
like
but-
it is simpler, it's just weird or.
No, it actually looks the same though,
Yeah,
just.
The division with boxes doesn't help as much. I have, if you go into my folder of to-doodles, there are some of them about different methods for division, 3 methods for dividing right here. So I talk about why dividing works in the box and the other kind of latticey method. Come on, internet, you can do it. Okay, anyway, but it's not as helpful as this. The multiplication box can actually save time and be as fast. The division box is just kind of something they do because they want to be modern. Okay, let's make sure that you're happy with things. So we could do these kinds of things. We could take the -3 and multiply it first by 2y and then by 1. So -3 times 2y is -6y. -3 times 1 is just a -3. And then you have to put the 7 and the -3 together. Okay. Do they get trickier than that? A bit. They talk about plugging things in. Yeah, simplify, evaluate. Everyone okay with simplifying and plugging in? Any of these you want me to do?
A refresher might be nice.
Which one?
A refresher might be nice, so really.
Pick a number and I'll do it.
226.
26, okay.
One on my own.
So I have -4. I'm just going to rewrite it a little larger. Times 3x minus 2. And then at the end, I subtract 6. If it helps you, put a little multiplication thing there. And if it helps you to think about terms, realize that this is one term. And then we have a plus or minus outside of the equal sign. There's no equal sign written, but I can kind of imagine there is one. So 2 different terms going on. Everyone okay?
Yeah.
Now I'm going to do what officially is called distribute, what we just did with the box. I have to take what's going on in front of this bit and apply it to both parts of it. You can draw the box if you want, but what's happening is first the 5 is being matched up with multiply 2x, and then the 5 is being matched up with -8. So I'll do that. -4 times 3x, well, -4 times 3 is -12. And it's x's. Notice the x's just kind of hang out, just like the zeros did up here. And just like the fact that if you had 2 zeros, one on the top and one on the side, they became 2 zeros there, then x's you'll find are going to combine together in a very similar way later on. Okay, -4 times 3x we did. -4 times -2, think about Peter Rabbit, negative times negative is positive, so we're at +8. And this term is just floating away like we did last time. So -12x +8 minus 6. If I have 8 and I get rid of 6, well, now I'm down to only 2. And I'm going to get rid of my equals because they're actually not asking us to do that yet. They just wanted to simplify it. So by the way, if you're in this book and you want to see your answers, then no, you go. Make it big. You click on tools and supplements and then selective answers. This is the odd numbered answers in the back that a normal textbook would have, but they put it in the ebook hiding under the tools pop out. If I shrink my screen though, you don't get to see this. And again, if you wanted to use this book, then the way they make money is they let you see chapter 1 for free. But anything after chapter 1, when you click on the link, you won't be able to go past chapter 1 without the password. And the account to use is my son. And the password is just password. But text me before you use the book so we can honor the contract and have only one person using the paid copy at a time. Sound good? Okay, let's look at the next section.
Is that same link, is that on the Moodle course?
Yep, it's this one, XYZ right here.
The,
It will tell you for each topic, like week 1, which
That's a
section
login.
we're doing.
to log in with your son's login?
Yep. And if we need more than one, because, Kasum Suk and Kalek start studying together every Sunday evening and they both want to look at it at the same time, then I can get another copy. It's not that expensive. But so far, I've never needed that. If you want to go back to the start of the course and then just look at the welcome and syllabus and look at resources, it's also right there. The textbooks are both here. The free one and the one with the login.
A lot of things that you buy the technical, but I can visit these.
Okay, we did 2. We have just a few more minutes. Should we work on solving some?
Yeah.
Okay. Let me jump down to one that's not an example problem. Okay, pick one of these.
What'd you say earlier?
I heard 47, which I think was 2 of them blurring together, but I can do a 47.
You do 47, that's fine.
Okay, so for x minus the quantity minus 4x plus 1 equals 5. This one, there's kind of an invisible thing. What does it mean to subtract a parentheses?
Isn't that like a -1?
Yeah, the easiest way to think about it is there's a -1 times all of that.
Yeah, that's
Shot in the dark.
huge.
It's 4x and or plus a -1 times all of that. That looks really awkward. You don't want to show up in public writing a plus and a minus together like that. But that's how to think about it. Okay, but so we're not embarrassing ourselves in public, I'll go back to what we had before, but that's what we're thinking about. We have a -1 that we're applying to both of these things. Okay, it is still true that on this side, we have one term and another one. We can deal with them separately. The first one doesn't have anything happen. It's just a 4x. The second term has that -1 to both of these. So a -1 just makes things negative. So a negative times a -4x, that becomes positive. And a negative times the +1 becomes negative. Everyone okay so far? So if I have 4 of something and 4 of the same thing, I have 8 of those things. It doesn't matter what they are, if they're X's or elephants or oranges. 4 of something and 4 more of them is 8 of that. And to both sides of the equation, I can add 1. I'm allowed to do that. And now I have 8x equals 6. We're back to those balance scales. I want to do the same thing to both sides of the equation, hopefully with not so sloppy handwriting. So the opposite of a times 8 on x is divided by 8.
5 times the 4's together.
And I get 6, oops, wrong color. And I get x is 6/8. And we should simplify that.
3, 4.
Okay, I urge you to write as much as I do. And let's look at how I'm writing things. First of all, I'm keeping my columns nice, right? My equal signs go down in a kind of straight line the whole way. These things are kind of a straight line the whole way. When I am doing the same thing to both sides, then I write it out. Why? Because sometimes I'm going to either be panicking because I'm taking a test and that makes me have brain farts, or I'm late at night or something. My kid is making noise, and I'm going to wind up doing a divided by 8 on one side and a divided by 6 on the other side. So it's worth the second it takes to write my red things, or burgundy, whatever nice color that is, write those things also. If you are going into 4-credit math, there will be a transition where if your instructor knows what he or she is doing, they will start the term writing these things. And then as the term goes on, leaving them out. And you can just know, oh, they did a +1 to get from one step to the next. They did a divided by 8 to get from one step to the next. But there's no reason in Math E to try and wean you off the burgundy letters or numbers. We're just going to keep writing that the whole time. And certainly on the GED test, take a moment to write it. You have time. It will prevent careless mistakes. You're going to lose more points on the GED for careless mistakes than you are for things you haven't learned yet. So take your time and be careful. And again, if you like calculators, you could just do 6 divided by 8 and have 0.75. There's nothing wrong with that. I'm just doing it the long way. Any questions about that? Okay, we're out of time, 3 minutes. Let me talk a little bit about homework and things. We can shrink the Miro and look at how much we got done. So lots of stuff we did. Yay. Is the online whiteboard working for people?
Yes.
Yes.
Okay.
So,
As we get more used to it, and as I'm there in person where things just go a little more smoothly, then I'll have more turns of you using the text boxes to do things. Today, I just wrote a bunch of stuff at the end, but you could have done that with text boxes. So we'll have you contribute a little more. And the whiteboard lets the people in Zoom and the people in the room work together nicely. Okay, what is your homework? Let's go back to the thing. First, this welcome and syllabus. If you haven't read through all of that, and I expect no one has, then do that because you'll have all the way from Thursday to Tuesday. When it's done, you can mark it as done. This isn't something that's automatic. You just have to click that you're marking it as done, and I will get to see that. This is not a class that's graded. You've had other ABSE classes. You know that these classes are not graded, but it's nice to kind of keep track and celebrate what you've done. We did a little bit of introductions in person at the start of last class. Please do some introductions. Type a little bit. Thank you, Pasum Suk, for doing that already. And a discussion starting off on the right foot. At least put in like hi or something, so I know it's working for you. The discussion starting off on the right foot is mostly for the people who are registered but absent. By LCC policy, they're going to get dropped from the class if they don't do anything the first week. So I have to give them something that they can do if their boss is mean and change their work schedule or something. But you could at least do a little bit so we know that you're here. And then your main homework is to go through this week 1 thing. You don't have anything to do with linear inequalities. We haven't talked about that yet. So when you get to the whiteboard, the MyOpen Maths, not whiteboard, when you get to the MyOpen Maths about that, just skip them from now. Don't do those yet. But you can look at the textbook sections in either or both textbooks, see what makes sense to you. I don't teach from the textbook, as you've noticed, very much, because the whole point is that I want it to use its different words and explanations from mine, so you get both. But look at them after class, see what works for you. I spent a bunch of time finding all the best videos, so watch any of those for whatever is your nemesis. We didn't go over all of the to-doodles, but if you want to look at that, you can. None of them are too complicated for you. The whiteboard just has a link to our whiteboard in case you forget where the link is. And then the MyOpen Math, only this week, there's some getting used to MyOpen Math stuff at the top, just to make sure that you're entering things in a way that it understands. And then here's all of the things. Again, skip the ones about inequalities and interval notations. Those 2 you don't know about yet. Or maybe you do, but you're not required to. But A through G, you should be able to get done before I see you. Since math is like a language, you don't want to do this all at once. Right? If you've ever tried to learn a foreign language, spending 20 minutes every day is a lot better than spending 2 hours on 1 day a week on the weekend. So with jobs and kids and everything else, that doesn't always work. But the more you can be like that, the better. And working in groups is incredibly better. If you don't have someone you're living with, friend, family member to work with, then try and get a classmate, and I can help with that. Just send me an email or a text saying, hi, it's Anthony. I want a study partner for Wednesday evenings or whatever, and I will try and match you up with someone and send out an email. Somebody is looking for a Wednesday evening study partner.
David, also tutoring.
Yes, and there's tutoring too. if you go in the main thing, there's a big
I liked it better on Zoom.
resources page. And I should also say something about Trio. Trio is the most amazing resource at LCC.
David, we got some questions here in the room, but tutoring is free. 5 days a week. They even do it on the weekend. You can make appointments on Zoom, or you can go to main campus or downtown campus.
Mhm.
And
Right
if
on the-
anyone needs help with that, you can always come to the downtown campus and we can help you do that, or David can, but it's super easy to do. It's a terrific resource. And you have a couple of questions in here, David.
Yep, let me finish one other last thing. If you don't have a study partner and don't find a classmate to work with, the last best thing is a stuffed animal. You would be surprised if you try talking to whatever, Peter Rabbit or somebody about your math homework. It works better than just doing it quietly in your brain. Okay, now your questions.
So even though it's not a graded course, you can still see what homework assignments are completed and everything, right? You can see scores for them and
Yes.
everything.
I can. I have turned off grading for you. And that's because when I put the things in the book, then it messes up the Moodle grader, but it looks so much nicer. So if you have seen other Moodle courses, then you get these like purple things and it just goes on. and on.
Do you need a break?
So I can't stand this much scrolling. But this is what the grade books wants to have happen.
They'll be here next week, right?
Oh, yeah, or just talk to them.
All right, well, then you and I will talk a little bit more next week.
Yep,
Is
if you want ever to see your own grades, I can try and figure out how to turn the grade book on for you. But it gets really ugly trying to scroll up and down, and by the time we're in week 10, the class just gets unwieldy unless you use these books. So that's why I've done it this way.
Right, I'm not trying to make your Moodle page any more complicated or anything. Like I said, next week we'll talk. I kind of have an interesting situation, so.
Okay,
Yeah, sweet. Other than that, have a good weekend.
then the last thing is pay a special attention because you're in class E about the GED info. There's all sorts of cute pictures and things about how GED works and practice test vouchers and stuff. If you've done practice tests, you know about this. If it's your first time this term to do a practice test, I'll talk much more about this when I'm here and can point at the screen. Okay, other questions? If not, you can run away, but let's do questions if you have them.
Or Chloe can show you how to create an account.
Okay.
To make the tutor.
Yeah, you said it was on just the LCC page, didn't you?
Yeah, so go to LCC, search tutoring, and then it'll come up, all kind of prompt, but I mean, like, if you need any help, I just walked her through the steps and she knows how to do it. So she was here. Is he still
Yep,
on there?
somewhere in the resources page, I put a great link to the.
We're just on the computer side, by the way.
You know, when we from them, we could just. Same level as we have lots of tutors. Today's next.
I thought it was right in the welcome. Yes, Lane Support Hub. So when you go to the welcome and class calendar, right on the first page under the e-ticket, you click on Lane Support Hub and it gives you this nice thing that they made up that talks all about all the tutoring things on one page. I can even put that in chat if people want that right now to bookmark. But that slide with all of their stuff is this link, Lane Support Hub, right there. Other questions? No, okay. Well, have a wonderful weekend. Tell me if you need some office hours, either in Zoom or once I get back to Eugene before Tuesday. And text me your email when you get questions. Do a little bit of math each day. Don't spend time being stuck. It doesn't help. If you say, oh, I tried this problem for 40 minutes, then you've just wasted your time for 40 minutes, right? Try a problem. If after 5 minutes that problem is your nemesis, skip it and go on. Ask about it in class. Make it everyone's problem and not your own. Any other homework tips you have for each other? No, okay. I hope you feel smarter after class and may your weekend go well.
Sure.
Enjoy your weekend.
Thank you.
Kayla, is the break time long enough for getting your kid in bed?
No, but I like watch